Okay, hello and welcome back. This is a tutorial on how to program video games using processing. I'm using processing 3.5.3. Um, and processing is a subset of the Java language. In my opinion, using processing to learn programming from scratch from the very beginning, first language that you use, I think is the best way to go. This is because you can it's easy to do graphics. Everything is set up here to do really easily. Um, so you can get basically like instant feedback from your programs. Graphically, which I think is like really important to kind of understand how things are working. And anyways, you can also, it's got a ton of like cool little examples that you can just copy and then or you can just go in and open one up and then modify them to kind of figure out how it all works, fits together. Um, so anyways, I'm not going to modify any examples, but I'm going to show you how to program this top-down two-dimensional game. The last tutorial I showed you how to scroll a map around and display a player on it. Um, so let me show you what that looks like now. So yeah, I have a player on here and I'm making the map scroll. Actually, last time, if you can see, the player didn't have any transparency, but I just changed the graphic around that I used to have transparency. So anyway, um, this is what I have so far. And this time what I'll do is I'll show you how to actually make sure that when you go to the edge of the map, it doesn't display like this blackness, empty void on the end of the map. It'll only go up to the edge of the map, and then the player will and then after the player gets to the edge of the map, then the player will continue to walk up, but the map will not move. So I'll show you how to do that this time. Also, I think I'll start to show you how to animate the player. So that's what I got so far. And by the way, yeah, all you have to do is just make an image with transparency. I actually created some images with transparency and it worked. I think I said in the last tutorial that you can't do that, but you can do it correctly in processing. You know, you don't have to do anything different than what I showed last time. You just use the load image function and you just load an image with transparency and it'll work. I don't know why I thought it wouldn't work in the last tutorial, but I was wrong. So anyways, um, so it's easier than I thought. So let's see here. So what we want to do is I'll actually make this bigger this time because I was doing it in a small window the last tutorials. Um, so let me see here. What we want to do actually is I think that the best way to do this would be to use a a new structure to coordinate all the drawing and everything between the player and the map, and we'll reuse this structure to coordinate the displaying the enemies and the items and everything like that that'll display on top of the map. Um, so probably the best way to do this is to create what we could call like a scene. That's kind of sticking to the terminology that Unity uses. So Unity is a game engine that's really popular and good. It's better than processing to learn how to program games, or it's better than processing to program games. But to learn things from the very basics, I think using processing is the better way to go because everything is just more simplified. Um, and let me see here. So anyways, um, what we want to do is the scene class will handle displaying the map and displaying the player and making sure that they're all in the right place when they display. So basically what we want to do is in this draw function, instead of displaying the map and displaying the player and having the draw function responsible for knowing how each of one of these things work, we'll tell the draw function simply to draw the scene, and then the scene will be responsible for knowing how all of its constituent objects and members actually work. So let me see here. First off, for every class, we're always going to have to create a constructor function, so I'll leave that empty for now. We're going to definitely put some stuff in there though. And then what we want to do is actually make a display function for the scene. So, basically we just say the scene display yourself, and then it knows all the details about how to organize everything and how to coordinate between all the potentially complex structures that we'll be displaying in our scene. So let's see here. So what we want, actually, one of the things that we want to do is we want to make it so that the scene has its own coordinates. So when you're scrolling around the level, really what you want to do, actually, you want to be scrolling like the scene view. Okay, so actually, I'll go ahead and I'll make a diagram here to kind of illustrate what we're going to do, so that you get a better picture of what I'm planning here. So basically, you have your map, and let me color that like green or something, like the grass. So you have your map. Just imagine that's a map. It has all kinds of different stuff on it, and then you'll have your player. So your player is like a small little rectangle like this. And also, you can have other things, like I'm saying, eventually we'll have also like items in the game. So you say like these are items on the map, blah, 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 blah. And you'll have enemies too, so you have like, there's a couple of enemies. Color these red so you can see they're bad enemies. Alright, so so you get your map. This is all the stuff that is on the map. So the player and the enemies can actually move around autonomously on the map. They can move to any different position as the frames are progressing. Like I was saying before, we might want like the map to center on the player when it can, or rather we want the scene view to center on the player when it can. So let me make a shape that represents like the scene view. So we'll say like this, say this is like a really big map, and this is the only thing that you can see on the screen would be this little box here. So I'm gonna make that transparent. So this is like the scene view right here. Maybe I'll also make it like dotted lines so you can see a little bit more. It's a little easier to tell what we're talking about here. So this is like the scene view, right? So with this thing, this controls like what you're actually seeing on the scene. So normally we want to have that centered on the player. So I'll actually zoom in here, zoom in. So basically, like what you would be seeing is just going to be what's in this scene window right here. Like, imagine like you're just looking in here. All this stuff out here you wouldn't be able to see. You wouldn't be able to see any of this out here. You just see this. This is actually what, the size of your window that you created in processing to do your graphics with. And so it's displaying the player. So say like the player wants to move up further. Say the player moves up here to the edge here. Let me see if I can grab this player here. I have to do it this way. Okay, so say the player moved up so that it's now centered at the very edge of the map. So you don't want the scene view to like go over the map so that you're seeing this stuff. This is like the blackness that I showed you on the edge of the screen before, like when you go upwards and you see this blackness here on the edge of the map. So we don't want to see that, typically. I mean, like you can design your game really however you want, but in my case I don't want to see that. So I want the scene view to just stop once it hits up here, but the player should be able to move further up. The player should be able to move all the way to the very edges of the map, and the scene view though won't, just shouldn't go off the edge. So anyways, so and then when the player, if it moves back down here or whatever, then the scene view will move, and wherever the player is, it'll center on, and you'll see other things coming into the scene as the player moves, and the scene stays centered on the player, whatever is like good enough. So yeah, so anyways, in this case you'd see like the player, and you see this item in here, and the scene would kind of move around as the player moves. So anyways, that's basically what we're gonna do. So I created let me see here, I'll go ahead and I'll actually create another drawing. Let's make copy. Okay, And okay, so I'm going to make what's called an object diagram now, so you'll see what I'm talking about here. So actually, let me see. I'll just move this down a little bit, and then I'll create this diagram. So say like this, these are the objects here. So we got we'll say this is our scene, um, and blah, 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 actually I'll make this lowercase to make it more kind of like, so you can tell, so it makes more sense. Okay, and then we have, makes more sense concerned with the code. So we got a player one, which we already created before. We have our map, which we already created before, and so these are the classes that we really want to consider. We also created a class for controls, but I don't really need to display that here. It's not really relevant to this, what I'm explaining. Eventually we'll have classes for the items and the enemies also, but we don't have those yet, so I'll just focus on the scene. So anyways, the scene is basically it's concerned with this this thing right here, which is the it's concerned with the scene view. It's what controls the scene view, basically, like what you're seeing on the scene. It handles like how this thing moves around. You know, in our case, we're going to say we want it to stay centered on the player, and then once it hits the boundaries, then it stops, and then the player can still continue to move around. But then once the player moves back into the center, then it'll continue to move with the player. So that's basically how the scene works. And then this class scene is going to, this object rather, is going to handle the mechanics of how to move this thing. So the player doesn't know how to move this. You can keep the player, and the advantage of that is that you can change around the way that the scene moves. Like maybe you want it to do some little kind of like trailing effect behind the player eventually, like to where the player moves and the scene kind of like, it doesn't just stay focused directly on the center. It kind of like flags a little bit behind the player and kind of catches up with the player as the player moves. You can do cool stuff like that if you want eventually. That's just the goodness of being able to separate these things out, is you can kind of like, you know, make it really basic at first and get all your other mechanics working, and then you can kind of like modify it eventually in the future so that you can do kind of cool effects with the scene. You can also do things like make like earthquake effects by just like making it like shake around and stuff like that. You know, whatever, any kind of cool effects that you want to do, it'll be handled in the scene, because the scene is concerned with only like how you actually view the things that are in the level. And then, you know, and then the player, whatever, the player has its own mechanics, like how does the player actually move around when you tell it to move. The player will handle that. And then how does the map actually, you know, what kind of things can the map have in it, blah, blah, blah. The map will handle that. And then the scene will just handle like how to view all those things all together. So that's pretty much what we're trying to accomplish here. So let me minimize this and close this. And okay, so we're creating our scene class. So in order for us to have, in order for us to know where this thing is going to display, like where this thing is relative to everything else inside of the level, we're going to need to give it a system of coordinates, or a set of coordinates rather. So we'll use the same way we did with everything else, p vector, and then we'll say position. So this is the same name as the player position, but it's a different class. So it's like this is like scene dot position. It's the position of the scene, as you can think about that, and this is the position of the player. So they can have the same name, but they're for different objects. So you know that's basically how it works. That's one of the advantages to using classes. You can do cool stuff like that. So let me see here. So the scene, we'll start it out with position. Oops. Okay, so we gotta, well, first off, we gotta make this is just a reference to a p vector. We gotta actually make it. We gotta make the reference point to an actual p vector, and we'll so now it's referring to an actual object of the p vector. We created an object of the p vector, and now it's referring to that. And then we're going to just make that start out at 0, 0. Really, what we should maybe do actually is make it center on the player. So let me see, and we can do that later, because we don't know in here that the player has been created yet. We can eventually move that logic to create the player inside of here, but right now I'm just going to focus on making it handle the display. So let me see here. So I'll make a function to make it center on the player. So we'll call it center on player, and this will just center the view on player. So let's see here. So what we want to do is actually this is actually going to have some kind of complicated logic here. So at first let's make it simple. So we'll say we'll pass in a player. Let's get player P. We'll call it in here. So we'll say position equals P dot position minus, and then we got width. Whoops. So position dot x we'll say equals P dot position dot x. So this is the player. So this is the reason why we call it P instead of the player one name here, as we have, even though this is like a global variable, we can use anywhere inside of we can reference anywhere inside of the game. Like you might have like player 2, player 3, player 4. So you want to explicitly tell it when you call this center on player function. You want to tell it which player to focus on. So that's what we're using. We're just going to use the name P to refer to it inside of this function here. So so it's saying position. So it's saying take my position dot x and set that equal to the whatever player that you're focusing on, which is named P, and set that equal to the player's x minus width divided by 2. So width is actually the screen width of the screen that gets created. So so in the setup function here, which like initializes the whole program, the first thing you do is you create the screen by using the size function. That creates the screen, and it creates it to the dimensions 800 by 800. It can be any dimensions that you want. It's just whatever you want to put here, and that will set the width and the height variables, which I'm using here. So I'm using it here. So the width is going to be that width that I set there in that size function. And then I'm just going to copy this so I can do pretty much the same thing with the y coordinate. So y position dot y minus, and that's going to be height divided by 2. So so that'll make sure that the view is always centered directly on where the player is. So so let's see here. So what we want to do, I'm going to go ahead and actually modify this these display functions. Instead of calling this here, so this is the display function for the player. Instead of calling this screen position, we'll call this offset. We'll call offset instead of screen position, because this could be an offset of anything, not necessarily just the screen, but it could be an offset of anything that we want to display the player against. So that allows us to like reuse it, and it makes more sense in whatever context that we're going to reuse it in. This naming rather just makes more sense in whatever random context it could be used in. So, and then we have the map. Also, the map will display. We want the map to display using the offset also. So let's see here. So what we want to do is for the offset, the way we apply that is that it's already kind of like displaying with an offset, which is the offset of this map position x, but that should actually add into this offset. So so we want to do, let me see here, I think it'll be map position dot x minus offset, whoops, caps lock set for some reason, whoops. Okay, so offset dot x, and do pretty much the same thing here for y, so plus the offset dot y. Alrighty, so so that should I believe make it display at the offset. We'll test this out. I'm not sure. I don't remember exactly if that'll work correctly, but so anyways, that will allow us to kind of change around the scene position, and the map will display, basically like in relative to where the screen view is, which is going to be denoted by this offset over here. So so let's actually think about that here for a second. So say you say this is like the screen is set to, the screen view is set to 50-50, which means that if the map was at located at the 0, 0 position, which is this, the point up here, which is what we're going to talk about when we talk about the coordinates of any of the objects. It's going to be the upper left hand corner of the object, because that's just how the coordinate systems work in processing. What we want to do is have this display at 50-50 into the world or whatever. So if the map is at 0, 0, that makes the math kind of easy here. So you could say that we're going to say the 0 minus 50. The map will display at 0 minus 50 from the screen, and this is, you can imagine, this is the screen. So this would be actually the coordinate in the real like space of the graphics, that we're actually displaying. This will be 0, 0 for the actual graphics, and like if you're thinking about like by pixel of the actual screen. So the map should display outside of that, the map should display at a negative value for the X and Y position. So it should display at -50, -50. Let's see here. And the player actually, the player actually should also subtract the offset from it. I added before that was incorrect in mathematics. So okay, so I think that should be enough to get it to display correctly. Now what we actually want to do is we want to change around. We set the this is the controls here. This controls what happens when you press a key or whatever the controls might happen to be. Whenever it uses the WASD, like up, down, left, and right system for the controls, and it was actually going to move the map. In this case, we're not going to move the map. We actually want the map to remain static inside of the, like you can imagine there's different kind of coordinate systems that we have, right? So the coordinate systems, whoops, looking at the wrong screen here. Okay, so the coordinate systems would be like, you have like the world coordinate system, and that would be this. This is like just a good way to do game programming, is that you want to make like a world coordinate system. So you got your world coordinate system, and this would be like the 0, 0 point of the world coordinate system. And then what you're going to have is then you have your actual like screen coordinates, which would correspond to the scene, whatever the scene is displaying, the view. These are the screen coordinates. So this would be 0, 0 in the screen coordinates, but this is 0, 0 in the world coordinates. So that allows you to kind of like move your screen over what part of your entire world that you want. So the world is going to be like bigger than your actual, typically it's going to be bigger than the actual screen that you display, so you can kind of like scroll and pan throughout the world. So that's the distinction that we're going to try to make here. And what we want to do, I just commented this out with these double slashes just so I can see what I was doing there. I might want to bring it back for some reason, but for now this is just, it makes the code like not active anymore. It's just basically like a note for me to see what I was doing. So anyways, what we want to do is we actually want to move the player. The player should move, its coordinates should change within the world. The map, we don't want its coordinates to change within the world. What we do want is the scene, the viewport into the world to change. So we'll say scene dot, we're saying that we want to just center it on the player, so whenever the player moves. So so we're going to call this center on player, scene.center on player, and then we're going to center it on player 1. So like I said, you could have eventually we'll have multiple players in there. Actually, this is giving me red because I didn't actually define an object called scene yet, but I'll do that. I just created the class to make an object called scene, but I didn't actually make the object called scene, so I'll do that in just a second here. So anyways, it should just do the same thing after each time that it moves the player. Actually, let me get rid of this comment here. I know I'm not going to need this. So alright, so so yeah, so each time the player moves, we want to just center the scene on the player again, because the player moved a little bit. So I'll go ahead and I will create this. Well, yeah, I'll create the scene first here. So we'll just create the scene object, and we'll call it scene. Again, this is the processing, and Java, which is based on, is they're case sensitive. It's a case sensitive language, so it makes a distinction between the uppercase and the lowercase here. So this is a good name that we can use for the scene object. So I created a reference to the object scene. Now I have to create the actual object. So I create an object of type scene, and that's it. I don't need to pass any parameters into scene to create a scene. So let me see here. So what we want to do. So the display function of scene, which I didn't actually define here. Like I said, we could go ahead and try to display the map in the player. Instead of displaying both of these things here and having the draw function like figure out like how to actually display everything, we want the scene to handle displaying everything, because the scene, it basically like it should know everything about the world, and then it should figure out like how to display the world. Also in the future we're going to make it like handle interaction between all these different things in the world, so like the physics and blah blah blah, all that stuff, we'll make it handle that for the interaction between everything. So anyways, right now we just wanted to make sure it displays correctly. So what we want to do, we could basically just take these, what we're doing in the draw function, and we'll just move them into the scene display method. So boom. So and then this is going to actually use the offset. So we want to put in the position of the scene as the offset, and instead of the map position for the player, we want to also use the position of the scene as the offset. So I think that should do it. What we want to do now is just tell the scene to display itself each frame. And remember, this draw function, it just constantly just gets executed over and over and over again while the program is running to display. And each time it gets executed, it's like one frame that it's displaying. So that should be it. Let's go ahead and run this. So I'm going to change around. So yeah, it's working now. It's not doing what we want it to do yet, but this is just, I didn't actually program it, the advanced behavior, to make it like stop the map from scrolling upwards yet and then have the player walk around. I just kind of moved everything into the scene class and just got it all ready so that I can make that change. So anyways, it's working. That's what we want to see right now, is it's still working. I didn't break anything. So let me actually, I'm going to just make a change to the map here real quick, because the way that it's displaying, it just kind of makes it hard to see everything the way I made it vary the tiles in the map. So I'm going to change, so this is the constructor function of the map. Remember this, whenever we create the map, it calls this function, and this basically initializes the map to whatever we want. So it was just kind of like using a weird little algorithm to select like how to set all the tiles in the map. I'm going to actually use the random function to set the tiles in the map, but what it does is it returns a floating point value. So instead of like an int value, which is like what the tiles are, it returns a float value. So a float value, again, that's a value that has digits past the decimal place, or it can potentially have digits past the decimal place, but integer numbers cannot have digits that pass the decimal place. Now, Java in processing, which is based on Java, it needs you to explicitly cast different data types into the one that it's going to. So the tiles, this is a list of integers. Tiles, you see, is a list of integers. So for each of the items in the list, which we reference using this I variable, this index variable, we need to set it to an int. If we're going to assign a value to it, it needs to be an integer value. So this is random, just naturally returns a float value. Instead, we want to return an int value. And I'm passing in 6. Actually, what I should pass in is map tile palette, being that each of the tiles is a reference to one of the tiles in the map tile palette. It's just an integer number, which is an index into that map tile palette, which is a list itself. So I'm going to put, just so we don't mess up in case we change the size of the length of the map tile palette list, we're going to use this map tile palette dot length, so that it always will use the maximum length of the map tile palette, and we have to worry if we make the change to the map tile palette if this is not going to, this will just automatically update with whatever number that we, whatever size of the map tile palette is. So, and then the random function, it generates a number from between 0 to whatever this number is. I'll let you ponder that on your own time. So there you go. So now I made the map really random looking. So whatever. I mean, that's maybe a little bit better than before. So I just wanted to make it a little bit easier to be able to see what's going on here, because the repetitive pattern that it was making before made it a little bit difficult, I think, to really see what was happening. Okay, so let's see. So now what we want to do, as I was saying before, now what we're going to do is let me get rid of this in the diagram. So what we're going to do is make it so that the view can go all the way up to the top here of the map, or the edge, whatever, any of the edges of the map, except for, and it will not go over the edge. This is what we want to do. We want to make it just constrained so that it always will stop at the edge of the map class. Okay, so here's the scene class. This is where we handle displaying everything. So when we center the view on the player, this is where we really want to make the change here. We could even make a different method, which is that maybe this is better to make a different method to do this. Let me see here. So we'll say constrain the map boundaries. What we'll do is we'll pass in a map M. We need to give the map the ability to tell the scene what its boundaries actually are, because the scene doesn't know like how big the map is necessarily. It would have to do some math to figure that out. What should happen is that the map should just tell it what the boundaries are. So I'm going to go ahead and create a couple of functions here. I'm going to call, and we're going to return integer values. We'll say int upper left boundary. I'm sorry, you know it was better actually. Left boundary, right boundary, and then lower boundary. And so these will just return numbers for whatever the boundaries are. So well, we can use the map position here for the left and upper boundaries. So we'll say map position. We'll say return map position dot y. Oh, whoops, I'm sorry. Left would be the x coordinate that we want. Return map position dot y. It's giving us this problem here because the p vector actually is a coordinate system of two floating point values, so we need to cast that into an integer value. And then the right boundary, we have to do some math here to figure this out. So it'll actually be, let me see, I'm going to copy this. So it'll be map position.x plus, what we do need to do to figure out this boundaries here is that we can take, so we want to take the size of the map. So this is the number of tiles in the x direction, and then this is the width of the tiles. So the size will be the number of tiles times the width. Rather the width of the entire map will be the number of tiles times the width of tiles. So we'll say, what is that again up here? Okay, size x and then tile y. So this will be size x times tile width. So that's how we'll compute that, and I will do generally the same thing for the lower boundary. So this will be map position dot y plus size y times tile height. So that's how we'll get the boundaries. And now the scene can use those to constrain its viewport to those boundaries. So what we want to say is if position dot x is less than m dot left boundary, then we can say position dot x equals left boundary, oops, m for map, m dot left boundary. Alright, and I'm just going to go ahead and copy this, so everything else is going to be pretty similar that we're going to do here. So then we got if position dot y, a little spacer to make it easier to read. Okay, so then we got if position dot y is less than m dot upper boundary, then we'll set it to the upper boundary. So it basically just like clamps it at these values. And then if position dot x is greater than m dot right boundary, position dot x equals m dot right boundary, and if position dot y is greater than m dot lower boundary, lower boundary, y equals m lower boundary. Okay, so I think that should do it to constrain the viewport to the map boundaries. So what we want to do is whenever we are centering on the player, as you see here, the controls, what we want to do is we want to move the player whenever the WASD controls are pressed, and only if the player moves is the only time that we need to really worry about changing the position of the viewport, because there's nothing else that can affect the position of the viewport in our game yet. But what we want to do is, in order, what we want to do is center the scene on, what we want to do is move the player first, then center the scene on the new position of that player, and then what we want to do is constrain the scene. So scene dot constrain, so this scene object is going to constrain itself to the map boundaries, and then we have to tell it which map to constrain itself to, so that's going to be map. And you could have multiple maps in your game, you know, so this is why we want to pass it in as a a parameter. So this will be the same for every time that we move the player. We'll just do the same type of thing here. Okay, so that basically is telling the scene what it wants it to do whenever the player moves. So let me see here. I'll go ahead and I will run the game, and let's see what happens now. So yeah, so now you see that you have the player moving around here. The map is not moving, but if I go down far enough, boom, then the map starts moving. If I go to the right far enough, boom, then the map starts moving. So let me go up here again and see it. It stops. Okay, so that stopped and the player kept moving. Okay, so that is what we want to achieve here. And I'll make the player, let me increase the velocity of the player so I can move all the way to the right side and the bottom of the map and just make sure it works at those positions. So it looks like the frame rate is actually going pretty slow, so I'm going to increase the velocity of the player to pretty high velocity. So boom, there you go. Oh, it's not working on that side for some reason. Alright, so let's see here. There we go, up, and let me see what happens when we go down to the bottom. Boom, doesn't work over here for some reason. That's a little bit strange. I don't really understand why. Okay, so so obviously we have a bug in our code. Boom. This is why it's important to always test after every little change that you make. And when you get really sophisticated, then you can start building in tests to your code to do automated testing. But anyways, I had a problem here. Let me go and look at what I'm doing just to make sure. I'm probably doing something dumb. Alright, so when we constrain everything here, we're constraining to the left boundary, constraining to the right boundary. So if the position.x is greater than the map's right boundary, then the position.x should equal the right boundary of the map. Oh, you know what? This is the problem here. Because if you can imagine, okay, so the position that we're talking about is this point right here. So if you move the map over like this, it's not going to stop until you hit that position. So You know what I'm saying? So it probably is stopping actually right when I hit that. You can't even see the effect of it because it's going so far, but it's comparing this point against this edge here. So what I need to do actually is I need to compare. I need it to stop like right here. So I need to compare this. I need to say if this point plus whatever this distance is greater than the edge of the map, then it will stop. So that's what I got to do here now. So I'm gonna close this. So I'll say if position plus um, let me see what will be. So it'll be position plus the width of the screen. Actually, is what I'm checking here. So position plus the width of the screen, and this will be position y dot the height. And then so we'll say, and then what we need to do here is set that to, okay, whoops, not width, height. So basically we're checking this, if this plus the width is greater than this right boundary, actually, you know, it will make it a little bit easier to imagine here. What I'm doing here is I'll put if this minus the width. So basically, you know, it's just kind of a different way of saying the same thing, except for the way that you have to do the assignment operation here makes it doing it this way make more sense. So whoops, minus height. Yeah. Okay, so instead I'm going to be comparing to the boundary minus the height, and then I'm going to be setting it to the boundary minus the height. So that'll make more sense. So let's see here what happens. Bloop. Okay. Yep, that makes a lot more sense now. So now it's working. So you got the map stops when the player moves towards it. Okay, great. So that's you know how you create a basic map and the viewport to view your level. And this allows you have like a basic framework that you can display any enemies. You can display like multiple players and have them all moving around independently of each other. And you don't really have to worry about, you know, thinking about where they're at in your scene. You just have to tell it to center on whichever player that you want to center on, and then constrain to the map size. If you actually even want to constrain it to the map size, you know, you might, for some reason, you might not want to at some points of your game, and some, you know, for some logic that you have in your game, you might not want it to do that. So anyways, you have a basic little framework to kind of do that. So next episode, I'll go ahead and I'll show you how to start doing animation on the player, and maybe we'll even clean up the map a little bit more to make it look a little bit better. Okay, so that's everything for this episode. Thanks again for watching. Yeah, make sure to check out my Patreon page if you can, and you can download the game. You can download a demo of the game that you can actually play through, and in the demo actually includes the code of the game and also all the graphics, so you can use the graphics instead of having to make your own, and then you can, you know, do exactly what I'm doing here in this tutorial using these graphics. I will actually make another tutorial on how to extract the graphics out of the demo file, or I might even just go ahead and post them up here somehow so that they're easy to download. But anyways, once you download the demo, it'll be like a Java package, and you have to kind of like extract everything out of the Java package. So I'll show you in another tutorial how to do that. Alright guys, thanks a lot. Take it easy and have a good one. Peace.